Okay, so we're going to look at ratios with algebraic values. Yesterday we looked at the different types of ratios with numeric values, and we looked at the ones with different types of units where we had to make them the same, ones with fractions, ones with decimals. So today we're going to look at algebraic ones. So let's start with 56xy to 16xy. Okay, so two ways that you can deal with this. You can either look at the number first and deal with that, and then deal with the letters, or you can deal with the letters and then look at the number. Now, what is the proper name for the number in front of letters like that? It begins with a C. What's it called?
Is it a coefficient?
Coefficient. Well done. Very good. It's a coefficient. So the number in front of the letters is called a coefficient. What are the letters called? Pronumerals, that's right, because pro in Latin means instead of, and numeral obviously is a number. So we've got 56xy to 16xy. Now, if you remember that these ratios can also be expressed like a fraction, if you do that, 56xy over 16xy, it shows why we can do what we can do with the letters. So what do you remember for when we were doing division with algebraic terms? If you've got an xy at the top of the quotient and an xy at the bottom, what can you do, Lachlan? You can cancel them out, that's right. So the xy can both be cancelled out. So all we're left with now is 56 to 16. And so what do we need to look for then?
Highest common factor.
Highest common factor, that's right. And what is the highest common factor of 56 and 16? 8. So my ratio simplifies to 7 to 2. Well done. Okay. Right then, so the next one we'll have 90x squared to 52x squared. And again, if you think of it as a fraction, you've got your 90 there and your 52 there. You've got your x squared and your x squared. What does x squared actually mean?
X times x?
Yeah, xx, doesn't it? X times x. But we don't actually need to write it in expanded form to do it. If you've got a very complicated pronumeral, it's actually quite useful to write it out in full because it's easier to cancel it out. But here you don't have to. So the x squared will cancel out. So you're left with 90 to 52. And what do we do then? Highest common factor, which is... Do they both divide by 3? No, I don't think they do. 52 doesn't divide by 3.
2? No. 2.
I think it's 2, actually, yeah. And so we've got 45 to 26. Anything else that divides in those?
No.
There's not, is there? No. Okay. So here, the last one, we've got 5x to 20x squared. Again, write it as a fraction, 5x over 20. And this time I am going to actually write x squared in expanded form, just to make it easier for cancelling. Okay, so I've got 5x over 20 x times x, which is x squared. So what can I do now?
Cancel out.
Yep, I can cancel one of the x's, can't I? But we're still left with an x at the bottom. Okay, so now we're left then with 5 to 20x. What do I do now?
Simplify.
Simplify it to
1 to 4.
1 to 4x. Because remember, you can't get rid of that x because there's nothing to cancel it out, okay? So here, because the xy was above and below, it cancels. Here, because the x squared was above and below, it cancels. But here, you've got an x and an x squared. So you can only cancel one of the x's, so you're still left with this x. Okay? Everyone with me? So that's really as hard as it gets for the ratios with algebraic terms. It's not particularly difficult. And if you remember what we did when we actually did a lot of division with algebra, you'll know what to do. Okay, so what we're going to look at now then is the unit rate in ratios. So when we have a unit rate, can anyone explain to me what a unit rate is? Go on then, Cody.
So like an example might be like, well, two terms, a term compared to another one, like generally a distance compared to.
Yeah, that's,
time.
we're talking about a unit rate in ratios though. So you're right when it's a unit rate with a rate, but it's called the unit rate in ratios. I know it's a bit confusing, but that's what it's called.
And it's where you have a ratio that's over 1.
That's right. It's where it's something to 1, okay? So the unit rate has to be something, okay, to 1. And the 1 always comes second, okay? So, and in a rate, when we're talking about rates, a unit rate would be $1.43 per 1 litre of petrol, $35 per 1 hour of work, that kind of thing, okay? So it's a similar thing because you're talking about it's something to 1, okay? Right, so let's have a look. We've got 3 to 3/5 then. So we've got 3 to 3/5. Now, we've obviously got to make the second bit of the ratio into 1 whole 1. That's going to be a bit tricky. So what do you think we need to do first? Tyler?
You put the 3 into the fraction.
Well done. You take the 3 because we need to get these terms either side of that ratio sign into things that are similar so that we can compare them. Because remember, a ratio compares 2 of the same thing. Okay? So this one, we're going to make it into fifths. So what is 3 as an improper fraction with a denominator of 5?
15.
Yeah, 15 over 5. Okay? To 3 over 5. Because we've not changed it. All we've done is change that into the same form as this. Okay? Now, what can we do if we've got a fifth on one side and a fifth on the other side? Or a denominator of 5 on one side and a denominator of 5 on the other side? We can cancel it, yeah. Because they're the same thing, we can cancel it. So we're left, because remember we're talking about ratio, proportion. 15 fifths to 3 fifths. So you don't have to worry about the fifths. 15 to 3 proportionally is the same ratio. Okay? So now we've got 15 to 3, but we've got to make the second part of the ratio 1. So what do we need to do to that 3 to make it 1? Divide it by 3. Very good. And what do we know about ratios? What do we have to do to both sides? Yeah, have to do the same thing. So we divide this by 3 also, which gives us 5 to 1. So the ratio of 3 to 3 fifths as a unit rate ratio is 5 to 1. So there are 5 equal parts there to every 1 equal part there. You with me? Yes.
I did it a different way and I got the same answer.
Okay, great. How did you do it?
I put the 3 over 1 and then cross multiplied and I got the same
Oh, okay. Yeah, you can easily do that. But I'm trying to explain to you how it works. Okay, why proportionally it's the same thing. But that's great. If you did it another way and it worked, fantastic. Okay, this time then, we've got a third to 3. So what do we do now? This has got to be something to 1. So, yeah.
Could you do it 9 over 3?
Yeah, you could. 1/3 to 9 thirds. Then we cancel that. Okay, so it's 1 to 9. So I've got to divide that by 9 to get the 1. So what do I have to do to the 1? Divide it by 9 becomes what? If you've got one whole one and you divide it into 9 equal parts, what have you got? 1/9, that's right. So it's 1/9 to 1. So 1/9 to 1. You all with me? Okay, right. And the last one, 4/7 to 12. And these are all taken directly from the maths space task. So these are the ones that you'll be meeting. So again, we've got to make this bit a 1. So what do I do first?
You would make the 12 an improper fraction, which would be 84/7.
84/7. Yeah. Cancel the 7s. What do I do now though? 4 to 84, and I've got to make that into a 1. Don't really want to divide that by 84, do I? So what can I do? Yes.
Simplify.
Simplify it first. So it's going to be 1 to what? 21. And then the same as there, it was 1 to 9. What have you got to divide the 21 by to get 1? Divide it by 21, and then you divide the 1 by 21, which gives you 1/21. So 1/21st to 1 is the unit ratio. Okay? Can you stop there then, please, do that?